Let's look at different types of numbers. So the first type of number we can have is a natural number. Natural numbers are positive whole numbers, and they are denoted by a capital N which has two lines going through the diagonal. Some examples of natural numbers are the following. So we can have the number 1, it's positive and it's a whole number, and so it's a natural number. We can have the number 2, we can have the number 57, we can have the number 1663, it's positive and it's a whole number. So -1 is not a natural number because it's a negative number. It is a whole number, but it's negative. Natural numbers must be positive. Also, 3.5 is not a natural number since it's not a whole number, it's a decimal, and we can't write this as a whole number. Another example is 4/2. So this number is positive, however it's a fraction, and we require natural numbers to be whole numbers. We could write 4/2 as a natural number since 4 divided by 2 gives us 2. But in this form, this is not a natural number. Now, one number that often causes debate amongst mathematicians is the number 0 and whether it's a natural number or not. 0 is a whole number. It's not positive, neither is it negative, since -0 and +0 have no difference in value. Depending on how natural numbers are defined, sometimes they include 0, sometimes they don't. So in this definition, this wouldn't include the number 0, since 0 is not positive. But if, for example, the definition was natural numbers are non-negative whole numbers, then 0 would be included. The next type of number is an integer. Integers are positive or negative whole numbers including 0. And the set of integers is denoted by capital Z with two lines going through the diagonal. Now, all of the examples and non-examples for natural numbers also apply to integers. On top of this, we can also have the number 3. We could have -10, that's a negative whole number. We could have 1257, and we could also have 6256, and even -6256. So we can't have 5.7 since it's not a whole number, it's a decimal. We can't have 1/2. We can't have the square root of 3 since the square root of 3 is not a whole number, it's a decimal. Similarly, we can't have the square root of 4, even though the square root of 4 simplifies to 2. In this form, it's not a whole number. The next type of number is a rational number. Rational numbers are numbers in the form p/q. So in other words, a fraction where p and q are integers. This is just a set notation for saying that. And q doesn't equal to 0. The set of rational numbers is denoted by capital Q. We use capital Q because we can call rational numbers quotients. Some examples of rational numbers. So all of the natural numbers and all of the integers that we looked at before are examples of rational numbers, since they can be written as fractions in this form. So for example, the integer -2 can be written as -2/1. 7/4 is also an example of a rational number. All recurring decimals are also examples of rational numbers. So for example, 0.3 recurring is a rational number, since it can be written as a fraction which equals to 1/3. Some non-examples of rational numbers. So non-terminating and non-recurring numbers are examples of numbers that are not rational. So for example, pi cannot be written in this form. Also, any square root which doesn't simplify to a whole number is also not a rational number. So for example, the square root of 3 doesn't simplify to a whole number. The square root of 67 doesn't simplify into a whole number. Imaginary numbers, which we won't look at in this video, are also non-examples. So for instance, the square root of -2 or the square root of -5. The opposite of rational numbers are called irrational numbers. Those are numbers that can't be written in this form, and so all of these non-examples of rational numbers are examples of irrational numbers. Real numbers are numbers that can be represented on a number line. The set of real numbers is denoted by capital R. Examples of real numbers include all of the types of numbers we've looked at in this video. All types of decimals are also examples of real numbers. Real numbers also include most numbers that are denoted by special symbols, such as pi and Euler's number. Non-examples of real numbers include complex numbers, which are in the form a plus bi, and imaginary numbers, which are in the form bi, where a and b are real numbers. We won't look at these in detail in this video. A quick side note is that capital C with a line through it is used to represent the set of complex numbers, and capital I with a line through it is used to represent the set of imaginary numbers. Therefore, for the set of integers, we use capital Z and not capital I.